Hello everyone, welcome to this presentation on Introduction to Computer Networks, a nuts and bolts view. My name is Sanya Sadaf and today we'll take a closer look at how computer networks function. Whether you're new to networking or just need a refresher, this video will cover the essentials, from the architecture of the internet to the protocols that make it all work. Let's get started. The Internet is often described as a network of networks, but what does that mean? Essentially, it's a massive global system that connects millions of smaller networks together. These networks could be anything from your home Wi-Fi to a large corporate networks, or even entire countries' infrastructures. These are the three key features that makes the Internet work. Global interconnection. It connects millions of networks across the globe, allowing devices everywhere to communicate. Open standards. The Internet relies on open protocols like TCP or IP, which ensures the different systems can talk to each other seamlessly. Dynamic routing. Data doesn't follow a fixed path. Instead, it dynamically finds the best route through the network. Efficiency and reliability. Now let's talk about how data actually travels across the Internet. These are several types of communication links, each with its own strengths. Fiber optics. These are the backbone of long-distance communication. They use light to transmit data at incredibly high speeds over long distances. Copper cables. These are more common in local networks like your home or office Ethernet connections. They are reliable and cost efficient for shorter distances. Radio waves. This is how wireless communication works. Wi-Fi and cellular networks use radio waves to connect devices without cables. And satellite links. For remote or hard to reach areas, satellites provide a way to connect to the internet even in the middle of an ocean or a desert. The network edge is where devices and users connect to the internet. This includes end devices. These are the devices we use every day like computers, smartphones, and IoT gadgets like smart speakers or thermostats. Access networks. These are the networks that connect our devices to the internet. Examples include your home Wi-Fi, mobile networks, or public hotspots. Users. At the end of the day, the network exists to serve people. Whether you're browsing the web, streaming a video, or sending an email, the network edge is where you interact with the internet. While the network edge connects users, the network core is the backbone of the internet. It's made up of high-speed routers. These powerful devices forward data packets between networks, ensuring that information reaches its destination quickly and efficiently. Interconnected networks. The core is a mesh of networks owned by different providers like ISPs and telecom companies. They work together to form the global internet. Data centers. These are massive facilities that store and process data. They host everything from websites to cloud services, making them critical to the internet's operation. Now, let's talk about protocols, the rules that govern how devices communicate on the internet. Without protocols, the internet wouldn't work. Here are the key ones. TCP or IP. This is the foundation of the internet. TCP, Transmission Control Protocol, ensures that data is delivered reliably, while IP, Internet Protocol, handles addressing and routing, making sure data gets to the right place. HTTP. This is the protocol behind the web. When you type a URL into your browser, HTTP fetches the web page from the server and displays it on your screen. DNS, the domain name system, is like the internet's phone book. It translates human-friendly domain names like google.com into machine-readable IP addresses. SMTP. This is the protocol used for sending and receiving emails. It ensures that your messages get delivered to the right inbox. Security is a top priority in networking. Let's break it down by protocol layers. Application layer. This is where encryption and authentication happen. For example, when you log into a website, your password is encrypted to keep it safe. Transport layer. This is where secure sockets layer comes in. It encrypts data in transit, ensuring that no one can intercept your sensitive information. Network layer. Firewalls and VPNs operate here. Firewalls block unauthorized access, while VPNs create secure tunnels for your data to travel through, even on public networks. To measure how well a network is performing, we look at three key metrics: latency, bandwidth, and availability. Latency. This is the time it takes for data to travel from one point to another. Low latency is crucial for real-time applications like video calls or gaming. Bandwidth. This is the amount of data that can be sent over the network at once. Higher bandwidth means faster downloads and smoother streaming. Availability. This measures how often the network is up and running. High availability is essential for critical services like banking or healthcare. And let's not forget the fun side of networking: smart devices. From smart watches and fitness trackers to connected home appliances, the Internet of Things is making our lives more convenient and connected. That's it for our overview of computer networks. We've covered the basics: how the internet works, the key components, protocols, and even a bit about security and performance. I hope you find this helpful. If you want to dive deeper, there are plenty of advanced topics to explore, like network design, cloud computing, and cybersecurity. Thanks for watching and stay connected.